Now let's look at Pezzoli number 4. They tell us we have this equation, the pressure, and this is probably a real equation that's used in chemistry. Pressure plus A over volume squared times volume minus some number B is equal to C. A, B, and C are constants. They could be 1, 3, 5, whatever. So they're just constants. So we want to find how fast the volume changes with pressure, dV dP. Okay, which means we have two options. We could solve for the volume, which does not look easy because we have a V minus B in the top, a V squared in the bottom. It might be impossible. I haven't tried it. But we could solve for volume and then take the derivative of it. The V will have a bunch of P's in it and then take derivative of it. Or we can do it implicitly. We can just take the volume with respect to P as we go across and do it implicitly, which is what they do in the solutions, and it's probably easier to do that. And then we can find dV dP that way. Now, one thing is here that these V's and P's can get confusing. So we could just think that, okay, V is like Y, okay, and P is like X, and what we want is Y prime. What we want is Y prime, because this is equal to V prime in a sense, so then we just do Y prime. So that might be, and that, you know, it can be confusing when you have different letters, like, wait, which one's like X, which one's like Y? So we could change the variables, and that might make it less confusing. So let's do that. If P is like X, everywhere there's a P, put an X. So X plus A, V is like Y, so Y squared times V is like Y, so Y minus B equals C. Okay, now we take the derivative with respect to P, which is X. We take d dx of the whole thing. Again, this is just implicit derivatives. Where we get a derivative of Y, it's Y prime. Okay, so this is a product. So it's a product rule. Derivative of the first times the second plus the first times the second. So, just diving in, derivative of the first, derivative of X is 1. So that's 1. Plus, so derivative of the first is derivative of this. So plus the derivative of A over Y squared, that's like AY to the negative 2, right? So A over Y squared is, I should have written that earlier, that's AY to the negative 2. So that's negative 2A, so plus negative 2A y to the negative 3, right? So the a's is a constant, so negative 2 times take away 1, yep, that's right. That's the first derivative of this first thing times the second times y minus b plus the first x plus a over y squared times the derivative of y minus b. Well, derivative of y is y prime. Oh gosh, and I forgot, we're taking derivative with respect to x here, so I forgot a y prime here. So when we take the derivative of y to ay to the negative 2, it's negative 2 y to the negative 3 times y prime. So I need to figure out y prime in here. Again, I need you guys to correct me on that thing. So we got to have our y prime in there. Okay. So now plus the first, that times the derivative of the second, derivative of y is y prime, derivative of b is 0, so that's just y prime minus 0, and equals the derivative of c. C is a constant, so it's 0. So that's nice. We want y prime. Okay, so we got to factor out all the y primes now, so let's make a sense of this mess here. So I have over here y times all that minus b times all that. So let's multiply the y through. Y times 1 is y. This is minus 2a. Y times y to the minus 3 is y to the minus 2, because right, y to the minus 3 is over y cubed. So y times that is y to the minus 2, which is y squared in the bottom. You know, I'm just going to show all my work here because this is kind of confusing. So let's just rewrite that top part there. This is 1 minus 2a y prime over y cubed. Y to the negative 3 is y cubed in the bottom times y minus b plus Let's multiply this through x y prime plus a y prime over y squared. Okay, now let's multiply this out. Y times this is y minus the y cancel the y squared, 2a y prime over y squared, minus b times that's just b, minus b times 1 is minus b, then minus b times this is plus 2ab y prime over y cubed, plus x y prime plus a y prime over y squared, and that all equals 0. That all equals 0. Okay, we want an equation for y prime. So we take out the y prime. There's 4 y primes here. That's crazy. So we have a y prime, 1 here, 1 here, 1 here, 1 here. So so we put all those terms and everything without a y prime I'm going to put on the other side, which isn't much. That's just the y and the b. Okay, so let's do that. Let's take out the y prime. So we have a y prime times, let's put the positive ones. Here we have an x. Let's put that one first, times x. That takes care of that one. Here we have a y prime times a over y squared, so plus a over y squared. Takes care of that one. And here we have to do the minus ones now. Minus y prime here times 2a over y squared. And this one is, oh, that one's plus 2. Okay, well anyway. Plus y prime times 2ab over y cubed. That's all the y prime ones. Taking out the y prime equals, on the other side, negative b becomes positive b. Positive y becomes negative y over here. Okay, well this is nice. We have a over y squared minus 2a over y squared. So that's just minus a over y squared. So these two combine to minus a over y squared. Okay, let's put those on the other side now. Divide everything by this whole mess, but these two can go into one. So I come on, voice. So we get y prime equals b minus y on the top, divided by all these things. We have an x, put the positive ones first, plus 2ab over y cubed. So that's this one, and these two combine to minus a over y squared. Okay, that's what I get there. Now, if we want to look like theirs, we can go back and replace the y with a v and the p with an the x with a p. Okay, so let's get their formula now. So y is the same as v. So our v prime then is b minus v divided by an x is like p. P plus 2ab over, let's see, y cubed is v cubed minus a over v squared. So, and that looks like what they got. They just put these two, they switched the order of those two. So, okay. So that's just basically that's just implicit differentiation. This problem is just dealing with implicit differentiation. Now, they give us numbers for part B. Okay, so this is obviously all part A. So let's look at part B. So part B says, assume that A equals 200. So now they're going to give us numbers. A 200, B is 0.2. And the pressure, and that when the pressure P is 20, the volume V of the gas is 10. So P equals 20 when the volume is equal to 10. 20 atmospheres, 10 milliliters. So just going to be careful with units. Use linear approximation to find the volume of the gas if the pressure decreases to 19. So we want to find V, and V was in milliliters, so our volume will be in milliliters as long as we stay with atmospheres, which we do. So find V when the pressure is no longer 20, when the pressure is 19 atmospheres. Okay, so then they want us to approximate to 3,000. Okay, so this is the linear approximation thing. We're going to make a linear approximation of the volume. Okay, so the way you do any linear approximation is, again, we use the formula for a line, right? So we think, okay, what's the formula for a line? What we need is 1 point, and we go y minus y1 equals the slope, which is x minus x1, where we have a point, x1 comma y1. Well, again, our y is v, so here the y is v, and our x is p. So let's rewrite this then. So we have v minus our volume point is equal to the slope. So the slope normally m is dy dx, but in this case it's dv dp. So it's equal to dv dp times x is p, so p minus p1. Okay, so what we need is the slope, the dv dp, when all these numbers are there, which we can get from our last problem. We just got to plug everything in. And we have our point, because our point now is v1, p1. No, p1, p is x. So p1, v1, which they gave us, p is 20 when v equals 10. So it's 20 comma 10. So that's our point. We have a point. v1 is 10, p1 is 20, and then we just need to know dv dp, and we solve for volume. So we got to figure out dv dp with those numbers. That looks like the first trick. So we got to go back to our old formula here and figure out what dv dp is by plugging in all those numbers. So v prime, or dv dp, dv dp, our slope, which was what we called v prime, is b minus v divided by p plus 2ab over v cubed minus a over v squared. That's a minus there, my minus and my fraction combined, minus that. And we just plug in all the numbers. So b is 0.2. We want to know when the volume is 10. 0.2 minus 10 divided by p was 20. 20 plus 2, a is 200. B is 0.2 divided by v cubed. V was 10. Just plug in all the numbers here. 10 cubed minus a is 200 divided by v squared, which is 10 squared. Okay, so that's a lot of math here. So what is this? 0.2 minus 10 is 0.2 minus 10, 9, negative 9.8. So negative 9.8 on the top. It's like 10 minus 0.2, but negative, yep, that's right. Divided by 20 plus, let's see, can we do this in our heads? 2 times 0.2 is 0.4 times 200 is 880. I better do that. So 0.4 times 200 on the top is 80 divided by 1,000. So that's 80 divided by 1,000 is 0.0. Okay, I better make sure I get my decimal places right. Yeah, 0.08. So plus 0.08 minus 200 divided by 100. I can do that. So minus 2. Okay, so that's negative 9.8 divided by 20 minus 2 is 8. Okay, whatever. 20. Oh. Plus 0.08 minus 2. That's 18.08. I can do that in my head. 18.08. So finally, what is that? Times 9.8. I get 0.5420, so we can say negative 0.542, the next one's a 0, so we can just stop there. So the slope is negative 0.542 at that point. So finally, we can go back to the other formula up there, and this thing here, so V minus V1, so V minus and V1 was 10, equals, that's our point, the slope, negative 0.542 times P minus P1. P was the X, which is 20, or let's see, V, the volume is negative 0.542 P. See, negative times negative positive, so what's that? 0.542 times 20. 20 equals 10.84. So 10.84, and let's see, it is positive, plus 10. Put this 10 on the other side. Or finally, the volume is negative 0.542 P plus 20.84. That is our linear approximation. Right? This is a line. Something slope is this plus the plus our intercept. So our linear approximation, we just need to know the slope, which we figured out, and we need a point, which they gave us. So now we want V when P is 19. This was when P was 20, right? We put in P equals 20. This is the exact thing. So we want now to use our approximation to find it when P is 19, which is close to 20, so it'll probably be a very good approximation, right? So the real volume is tricky to find, but so this is an approximation to the volume. So now we just plug in P equals 19. So the volume at 19 is negative 0.542 times 19 plus 20.84, which is 0.542 times 19 is negative 10.298 plus 20.84, which is equal to plus 20.84, 10.542, 542, that's what I get. So the volume is 10.542, and let's see, we're dealing with milliliters, so we should put some units there, so milliliters. Okay, and that's the answer they got too, so good for them, they did this one right. Okay, that's how you do these, a linear approximation, which means you just use the formula for a line. Be careful again with y is v, and the slope is dv dp, which we found. They give you a point. I find it really helps think of y's and x's and then just switch the units like this and be really careful with the points like I was over here. And then it makes more sense. Okay, thanks for listening.